Alright, last video we talked about the hydrophobic side chains, or also known as the nonpolar side chains. This time we're going to talk about the hydrophilic side chains that create the hydrophilic amino acids. And the reason they're called hydrophilic, what hydrophilic means, as we talked about a couple videos ago, is water loving. And the reason they are water loving is because they are polar. That's another name for these. Some books and references will refer to these as the polar side chains. Okay. And the reason we call them polar and the reason they are water loving is because when we think about the water molecule, the oxygen and the two hydrogens aren't symmetrically distributed about the oxygen atom. They are instead, they fall kind of to the same side, creating this quasi-polar appearance. So this would be the positive side because of the two hydrogens, and this would be the quasi-negative side because of the oxygen. And so the things that are going to be water-loving, or the things that water are going to be attracted to, water molecules are going to be attracted to, are things that have a pole. Either a true pole, meaning they are they are ions, anions or cations, just they have some sort of electric charge, or they are also going to be polar, quasi-polar, in that they contain an oxygen molecule. And just like the hydrophobic side chains, there are 10 of these, which is more coincidence than anything else, but it is convenient. And we're able to separate the hydrophilic side chains into 3 different families. So there's 10 side chains, and the families we'll separate these into are the acidic side chains, which there's 2 of, the basic side chains, which there's 3 of, and then the uncharged polar side chains. Okay, these 2 right here are ions. They're charged, as opposed to these 5, which are uncharged. Okay, so let's just go ahead and we'll start with the acidics. There are 2 of them, and we said in the last video, when we're talking about our R group, actually let's go ahead and redraw the structure of the amino acid. I'm going to turn this one sideways just to give me a little bit more convenience here. So we have our alpha carbon, our normal hydrogen, our carboxyl group, and our amino group. And then we have our R group. And with the exception of glycine, which we talked about last time, all of the rest of the side chains, their first the first carbon, or the first branch of the R group is a methyl. Okay, or let's just say a carbon. We won't say a methyl. We'll just say a carbon of some kind. And so for the first acidic side chains, all we have is a carbon and then another carboxyl group. Actually, let's draw this out. We have and you see, as I put on this carboxyl group, I put the negative charge here because, like we said up here, these are ions, and this is at a pH of 7, which is a bodily pH. So that's the first one. This is called aspartate. aspartate, also known as aspartic acid, because this is an acid, right? And that is abbreviated ASP. Now this one, its shorthand, its single letter notation is a D, and that's just something that we have to memorize. All right. The next one is not much more complicated. The first of the R group is another carbon like that. Then we have a second carbon before we have our carboxyl group. Okay. Also, which is an acid, and also which is charged. This is called glutamate. And like I said in a previous video, I apologize, but this is just one of the things that we kind of have to memorize. And I'm presenting it in a way, hopefully, that is a little bit logical, puts a little bit of a pattern to it. That way, it kind of makes sense as we go along, and we can group them in these little subgroups: hydrophobic, hydrophilic, and of the hydrophilic ones, we can separate them into acidic, basic, and uncharged polar. So now let's talk about the basic groups. The basic groups. And so, talking about the R groups for the basic groups, you again start out with this first carbon here. This one forms a chain, actually, of 4 carbons before terminating into a nitrogen group. And now, whenever you're talking about organic bases, especially in biochemistry, a lot of them are going to be nitrogen based. And actually, all of these basic side chains are going to have a nitrogen associated with them. And this first one just has an ammonia group there at the very end. Okay? Or an amino group, we should say. And this one is just called lysine, abbreviated LYS or K for short. And the reason it's abbreviated K instead of L is because L is already taken by leucine, which we talked about when we talked about the hydrophobic side chains. Our next basic side chain we're going to talk about is called arginine, and this one, like lysine, begins with a carbon chain, or a hydrocarbon chain, I should say. But this time, instead of 4 carbons like lysine, this one only has 3 before it there's a nitrogen in the chain. However, this nitrogen is not the terminal part of this side chain. This one then continues on with another carbon, and that carbon then branches into 2 nitrogens. And if you'll notice, this nitrogen now makes 4 covalent bonds, a double bond with this carbon, and then 2 bonds to a hydrogen. And when you know from organic chemistry that when a nitrogen makes 4 bonds, it obtains a positive charge because it's essentially has less affinity for the electron than the carbon does. And so, since it's kind of giving up its electron, then it gives it to the carbon. This nitrogen up here, this charge should be positive. I apologize for that. Continuing on with the third and final. Oh, let me name this one. This one is actually named arginine, and that's abbreviated ARG, or simply R. Think of a pirate whenever you're talking about this. Arginine. And the third and final one is called histidine, and it, again, like all other side chains except for glycine, begins with a hydrocarbon. But this one has this carbon, which then continues to another carbon, and in this actually forms a ring, a 5-member ring. And if you draw it this way, there's another double bond with a hydrocarbon, which then goes to a nitrogen. Double bond to another carbon. Another nitrogen. And then it connects back to that form that ring. If you'll notice here, this nitrogen, like this one up here with arginine, makes 4 covalent bonds. One with the carbon, 2 with this carbon, and 1 with the hydrogen, giving it a positive charge. So if you look at all of these nitrogens, they all have 4 covalent bonds, giving them the positive charge. Because of their basic character, that's why they're able to hold on to these extra hydrogens. And because they have this positive charge, that's why we call them polar amino acids, and that's why they have the hydrophilic properties. Right. Now, unlike the acidic and the basic side chains, this last group of side chains we're going to talk about are uncharged. Hence their name, uncharged polar side chains. And now, just because they're uncharged, or because they're uncharged, one might argue, well, they should belong in the hydrophobic. However, they obtain, all of these are going to have an oxygen, which, as we remember from the structure of water, oxygen forms bonds in a way that kind of makes it polar, or I've used the term quasi-polar. And all of these obtain oxygen, or contain oxygen, which gives it that hydrophilic state. So the first one we're going to talk about is going to look somewhat familiar to you, and it's going to be named somewhat familiar, and hopefully you can use that whenever you're memorizing these names. Like normal, our group is going to begin with a carbon, and then it's going to go to a second carbon, which is then going to form a double bond with oxygen. Remember, we said all of these have oxygen. Now, you might be thinking, well, this is looking a lot like a side chain we talked about earlier, specifically aspartate, when you notice that this R group begins with a carbon, which then connects to another carbon, which has a double bond to an oxygen. But instead of aspartate, which, as we can see right here, connects to another oxygen, which then loses its hydrogen because it's an acid, and thus becomes a negative charge. This one over here connects to a amino group, specifically an amide group, because we have the double bond oxygen connecting to a nitrogen. And you'll notice that this nitrogen only has 3 covalent bonds, 1 to the carbon and 2 to the hydrogen. And this is how it is in the body at a pH of 7, and thus it's non-charged or uncharged, but it's still polar because of the oxygen. And now you remember the last one, or the one that is the acidic, it's called aspartate or aspartic acid. This one is called asparagine. And you might memorize this as aspartate plus amine. Might make it easier. And this one is abbreviated ASN. Can't be ASP because that's what aspartate is. And then this one is shortened by the letter N. If you remember from the hydrophobic chains, it can't be an A because that is alanine. Continuing on, likewise, how asparagine is to aspartate, this next one is very similar to asparagine, except for we have a chain of 3 carbons of 2 carbons before we get to our amide group. And this is very similar to this chain right here, which should be called glutamate. Also known as glutamic acid. This one over here, likewise, is called glutamine. Glutamate plus amine. And this one is abbreviated GLN or Q. Now that's kind of confusing, and unfortunately that's just one that we're going to have to memorize. The G is already taken by glycine, which we learned about in the hydrophobics. Alright, and now these last 3 that we're going to talk about are a little bit, I would say, simpler. They're just going to have a simple alcohol group on them. But as we talked about, alcohol groups we know have a hydroxyl group, and the oxygen is key. So this first one, the R group, starts with the carbon and then goes to the alcohol group. Okay, this one is called serine, abbreviated SER or S. Simple enough. The next one is called threonine, and like serine, has a carbon and then an alcohol group, except for that first carbon there branches into another methyl group. Okay, and this one is called, like I said, threonine. THREONINE, abbreviated THR, or just T. Then finally, this last one is going to look a lot like one of our hydrophobic chains. Remember we talked about phenylalanine, which was just an alanine, which if you'll remember from the hydrophobic is simply the R group with a methyl group here. But then phenylalanine branches into a phenyl ring. What this one does is then that on the opposite side of that phenyl ring is a hydroxyl group, making it an alcohol. This one we call tyrosine. And it's abbreviated TYR or Y. Again, I apologize because of the nature of these. They really only can be memorized. But hopefully I presented them in such a way that they kind of make sense and they can have some order to them. Remember things like aspartate and glutamate looking very similar to asparagine and glutamine. The only difference, this is the acidic ones, aspartate and glutamate, or aspartic acid and glutamic acid, they have carboxylic acids as opposed to amide groups. Or you can remember things from the hydrophobic like phenylalanine. Anyway, good luck in memorizing these, and watch the videos over again if you need help.